We will discuss moon called galvanometer. Now we need to discuss conversion, right? Actually, galvanometer basically it rotates depends on the amount of current which is flowing through that, right? So more the current, more the deflection we can find out. That is to the galvanometer, right? Then next, apart from that, how galvanometer can be used as a ammeter, how galvanometer can be used as a voltmeter, we get to know here. This is the most important thing because whatever we are discussing this topic usually it is also practical based for us. Practical based in the sense that is when in practical while we are doing galvanometer and how much it is deflecting depends on the amount of current flow and depends on the amount of resistance. So with different resistance we will check, we will find this how much it is deflecting from original position to certain position. That is we call as figure of merit, the angle how much it is deflecting. Okay, that is normally in practical we will take. Therefore, this all we will take as a constant. I is directly proportional to the alpha we will write. Now, radial magnetic field also we were discussing. This is with respect to a mirror method we convert. Here you are finding current sensitivity of galvanometer. What do you mean by sensitivity? Sensitivity in the sense the measuring capacity for the small changes also it will be shows the measurement. Okay. Here with respect to uh, current sensitivity of galvanometer, what we need to discuss. If the deflection of galvanometer per units current if you are taking means small amount of current to the galvanometer also increases, then obviously the measuring capacity, the deflection capacity will be increased. That we say here current sensitivity. That we will write, we will express whatever the deflection I said, alpha, alpha per unit current I if you are taking. More the current, okay, means per unit current, the measuring capacity or the deflection in the needle we can find out. That gives the current sensitivity of galvanometer. That is we write as alpha by I here. Okay. So NAB by K is all are constant form. Now coming to the voltage sensitivity of galvanometer. Current sensitivity you know like this. Voltage sensitivity in the sense per unit voltage how it shows the deflection. My meaning is that when galvanometer is used with respect to current, then per unit current. When galvanometer is with respect to voltage, per unit voltage, it shows the deflection. Same deflection per unit voltage, if you wanted to find, then NAB by K into R. Obviously, here I equal to, from the Ohm's law, I equal to V by R we will write. So this side V in the sense, this side R will go. Now, how the sensitivity has taken, you will understand from this. Conversion of galvanometer to ammeter. Sir, first of all, why we need to convert? What is the possibility? In what cases we will convert? Let us say in a physics laboratory, there are all our meters are spoiled. We don't have ammeter, but galvanometers are more. So then that galvanometer, how can I use as an ammeter in the laboratory? So that time, what I will do, usually, you know or you don't know, we were discussing current electricity also. Why voltmeter connected in a parallel, ammeter connected in a series in the circuits? Because ammeter offers very less amount of resistance to the circuit. Okay, and whereas voltmeter offers large amount of resistance to the circuit. This point I raised in a potentiometer also. In potentiometer, you wanted to measure any EMF of any cell, we can use potentiometer to get accuracy, to achieve 100% value or 99% value. But whereas if you use voltmeter in such case, since it is offering high resistance, so we cannot or we are not able to measure EMF of the cells very clearly. Okay. Okay. Since ammeter does not offer high resistance, I can connect it is in series. So, but I don't have ammeter, but I'm using galvanometer as an ammeter. What is the job of galvanometer? Basically, separately galvanometer job, if you see, it measures the weak amount of currents in the circuits when you connect. Any due to any magnets or magnetic fields, extra amount of currents are generated or induces that can be understood from this galvanometer. How this galvanometer is used here as an ammeter now? That we are going to see. Let us say, since it is offering high resistance, sorry, less amount of resistance, in the same way we will convert circuit also. This is a galvanometer, right? So galvanometer's resistance we need to decrease because I'm using it as an ammeter, right? So what I'm doing for decreasing resistance, how can I do? Whatever extra resistance I'm connecting this while I'm converting, I'm connecting in parallel. Since I'll connect in parallel, whatever this galvanometer resistance is there now, this resistance value will be decreases. Okay, this resistance value decreases whenever I'll connect this in parallel. Okay, so this parallel connection we called as shunt. What we say it is shunt. Shunt means here bypass connection like this. Okay, so now whatever the current is going through this galvanometer, it is divides like this and it's flowing through this also. Now you can see here, whatever I said, we have connected shunting with a very small resistance. Due to that, current will be reduced and it allows to flow through the galvanometer. Now, potential difference across the galvanometer and shunt resistance are equal. Means whatever the resistance, whatever the potentials we are taking at this point and at this point, at this point and this point same. Because we know that in parallel potential is constant, right now. So from that, we know total amount of current and resistance is gives us I into Im energy through this resistance is equal to Ig into capital G. Here capital G is considered as resistance in galvanometer. Okay. Here S is resistance in the parallel resistor, nothing but shunt resistor we say here. Now from this, further, if I wanted to make this shunt resistance as a subject. So S I made as a subject, then I send this side. This is the formula for to find the shunt resistance. Anytime you wanted, you will have a questions most of the time in exam to find the shunt resistance. Shunt resistance is equal to Ig into capital G by I minus G. Now, here, how we have converted a galvanometer as an ammeter. So we can have, we are indirectly, we are dividing the resistance and with respect to that, we can also, we are also managing the current here. Therefore, we can measure easily from the galvanometer uh, current. Means galvanometer is acting as a ammeter here. Just because of nearly equal resistance or small resistance which you are connected in parallel. Then this totals up to this called as ammeter now. Now same way, what I am doing here, next topic, conversion of, what is the next topic?
Conversion of galvanometer to
Yeah,
voltmeter.
voltmeter. Now, sir, as I said just now, ammeter offers less amount of resistance. Still, we have divided that. What we are dividing? We are dividing the current. Okay. But voltmeter, you wanted galvanometer work supposed to be behave as a voltmeter in the sense. What we have to do? We have to increase the galvanometer resistance. For increasing the galvanometer resistance, what we will do here? Extra resistance I have added. What I did here? Extra resistance I have added to the galvanometer. Got my point?
Yes, sir.
See, whatever the blue data lines you are seeing, this is total is voltmeter. Voltmeter always connected in parallel. Look at here. This is the external circuit. For this external circuit, we connected in parallel. So, extra resistance since are connected to a galvanometer, then voltmeter resistance has increased. What happened here? Voltmeter resistance has increased. Sorry, galvanometer resistance has increased. Then it behaved as or behaving as voltmeter. Since it offers high resistance, obviously, to that less amount of current flows takes place. Then we can write it as potential difference across the given load resistance is sum of the potential difference at galvanometer and potential difference across the high resistance. Got it?
Yes, sir.
See, now voltage. Since we are measuring voltage in the any circuit, so this is the points we are taking. When I am finding the voltage uh, between these two points, V equal to I into R, we know basic Ohm's law. So I is the current, G is a galvanometer resistance, R is the extra resistance which we have connected in the circuit. Right? So therefore, if I make extra resistance which I have connected as a subject, R equal to V by Ig minus capital G, I can write that. Ig minus capital G, I can write that. Okay. This is the way we can convert galvanometer to ammeter and galvanometer as a voltmeter at times. Okay, but everywhere remember the concept is same. That is which works on the base of Clemens left hand rule motor concept only works out here. Because how much amount of current flow depends on the deflection takes place inside the coil. Okay, and these are the devices mostly response or works for DC currents, not AC current, not for alternating currents. Okay, next. Is it clear up to here? Any doubt?
Yes, sir, it's clear.
Next, we have differences between them. Just we will have a quick revision or a quick idea we will get for the exams also. It becomes easy. Ammeter and voltmeter. One you are taking ammeter. How it is? It is having the low resistance. We know just now we see, and voltmeter having always high resistance in the instrument. And resistance in the formula which we got GS into G into S by G plus S because parallel formula. This is series formula G plus R we will write. And center resistance formula G into Ig by I minus Ig we have written. It's very small. And series resistance is V by Ig minus capital G and is very high. It is always connected in series. It is always connected in parallel. Resistance of an ideal ammeter is zero. Resistance of an ideal voltmeter is infinity. This what? Ideal, I said. Since it is ideal, in the sense it offers more resistance, okay, it is zero in this case. Voltmeter means it is offers high resistance. Its resistance is less than that the galvanometer resistance. Ammeter resistance is less than that the galvanometer, and that's why we have decreased the galvanometer resistance here. Here greater than the galvanometer resistance for the voltmeter. That's why what we did here, we have added to the galvanometer, then it is acting as a voltmeter. Here it is not possible to decrease the range of the given ammeter. It is possible to decrease the range of given voltmeter. Means you can decrease the range of the values voltmeter since it is offers higher resistance. But current ammeter itself is having very less amount of current will measure. It is very not feasible to decrease the range. This is all the differences between ammeter and voltmeter. Now we will have a few numericals on this.